Hello everyone, I am Soumyashree Senapati. In our previous lecture, we have already calculated normal stress and shear stress in inclined plane. So, and just got the value here. So, now to find out the resultant stress, we have the formula as square plus tau theta square. Okay, and we need to find out the phi, that will be tan phi equals to what? So, tan phi equals to sigma theta upon tau theta. Okay. So, now we will solve this one. So, our sigma r, this is our resultant stress, will be over of sigma theta square plus tau theta square. So, we already have these values. So, we can use under root px upon a cos square theta whole square plus px upon 2a sin 2 theta whole square. Okay. So, px upon a we have in while we are calculating vertical plane. So, here you can remember from this object, while we are calculating stress in case of vertical plane, we have the force here Px and we take the area as A and we have sigma x as Px upon A. So, now we can put that value here in this part. So, our Px upon A will be sigma x cos square theta whole square plus, we will take this part sigma x by 2 into, we can write the sin 2 theta as 2 into sin theta into cos theta whole square. Okay. So, now sigma r will be, okay, here we can cancel this term 2 with this 2, right. So, now we have, so we can take the common as sigma x here, sigma x square and cos square theta, right. So, now we have cos square theta plus here this one sin square theta. Okay. If just this part we take here, so we will have sigma x into cos theta under root cos square theta plus sin square theta. So, in trigonometry we already learned that sigma r will be this part root under root cos square theta plus sin square theta will be 1. So, now we have sigma r as sigma x cos theta. Okay. We have the resultant stress as sigma x cos theta. Okay. And So, phi is equal to tan inverse sigma theta upon tau theta. So, phi will become tan inverse, we can put sigma theta and tau theta value. So, we can put sigma x cos square theta upon sigma x theta into cos theta. We can write it like this. Okay. So, this is our what? As we know, tau theta is sigma x by 2 into sin 2 theta. So, tau theta will be sigma x. We can write this sin 2 theta as 2 sin theta into cos theta. Sigma x by 2 into 2 sin theta into cos theta. So, this 2 cancel. Now, we have phi equals to tan inverse sigma x cos square theta upon sigma x sin theta into cos theta. Now, we can cancel this cos square theta with this cos theta and sigma x with sigma x. Our phi will be tan inverse cos theta upon sin theta, it will be cot theta, tan inverse cot theta. Then from this, if we have the theta value, we can find out phi. So, here we have the resultant stress. Now, we have the values of sigma theta and tau theta for inclined plane and also for vertical plane. Right. So, sigma theta for inclined plane will be sigma x cos square theta and tau theta will be sigma x. Here you can see tau theta will be cos theta into sigma x upon 2, that will be cancelled, sin theta into cos theta. Okay. That will be sin 2 theta. We can take it as usual. So, here we will take it as px by 2 cos square theta and px by 2 sin 2 theta. It will be easy to find out the angles. Okay, and here sigma theta equals to px upon a and tau theta as 0. So, now we put different angles in case of theta. So, we will have the values at different angles. So, first at theta equals to 0 degree, we will have sigma theta as px by 2 cos square theta. Cos square, we will take cos square 0 degree. So, we know cos 0 is 1. So, sigma theta will be what? Px by 2. Okay. And if we put here in sin 2 theta 0, So, our value will be tau theta equals to Px by 2 into sin 0. We know that sin 0 is 0. So, tau theta will be 0. Okay. Now, we have sigma theta and tau theta for theta equals to 0 degree. Now, at theta equals to 90 degree, we will have sigma theta is equals to cos square theta is cos, we will take cos 90 degree. So, cos 90 is equals to 0. Now, for theta equals to 90 degree, we will have sigma theta is equals to 0 and tau theta is equals to Px upon 2 sin 2 into 90, that is 180 degree. It is also 0. Okay. Next, at theta equals to 180 degree, we will have sigma theta equals to Px by 2 cos 180 degree. So, here sigma theta will be Px by 2 as it is cos 180 degree equals to 1 and tau theta equals to Px by 2 sin 180 multiply with 2, that is 360, and it is also tau theta equals to 0. Okay. So, till now we have normal stresses, different normal stresses at different angles, but shear stress is 0 at 0 degree, 90 degree, 180 degree. But to find maximum shear stress, what we will do? We just need to put this theta will be 1. So, now if we put theta is equals to 45 degree, if theta is equals to 45 degree, so tau theta will be Px upon 2 into sin 2 theta, that will be tau theta equals to Px by 2 into what? Sin 90 degree, and tau theta will be Px by 2. This is our maximum shear stress. Okay. Now we have maximum shear stress. To find out minimum shear stress, we need to find out this theta as -1. So, if we put theta as 135 degree, so our sin 270 degree will be -1. Okay. So, by putting if theta equals to 135 degree, tau theta will be Px upon 2 sin 2 into 135, that will be tau theta equals to minus of Px by 2. This is our minimum shear stress. Okay. Now we have maximum shear stress and minimum shear stress. But here, if you can see in this part, shear stresses are 0. So, as I have already told you that if in case of any plane there is presence of shear stress is 0, so we will tell that we will take that plane as principal plane. So, here we will take that object as A, B, C and D. So, when theta is equals to 0 degree, sigma theta will be Px by 2. Here uniaxial load is applied already, that is our Px. Okay. Due to Px there will be sigma x. So, in theta equals to 0 and sigma theta equals to Px by 2, and here at 0 degree, theta equals to 0 degree, tau theta will be 0. So, if we see as in this vertical plane, okay, we will take the example of here at vertical plane, if we see in anti-clockwise direction, okay. So, first in 0 degree, like in this plane, what will happen? Sigma theta will be Px by 2. So, we will take that as it will be our principal stress, and in case of principal plane there will be two stresses, one is maximum principal stress and another one is minimum principal stress. So, at theta equals to 0 degree we will have sigma 1 and we will take that as maximum principal stress. Also we can tell that as major principal stress. Okay. Now, at theta equals to 90 degree, theta equals to 90 degree, here we already have the values, theta equals to 90 degree, we have sigma theta equals to 0. If it moves in this direction, theta equals to 90 degree will be here. So, like if we caught this object in horizontally, there will be no stress. The action of stresses will be 0 here. Okay. If we caught this object, the structure will become like this. So, we can see the stress is acting in this direction, there is no stresses acting like in this way. So, here we can see sigma equals to 0, that is our normal stress equals to 0. In case of if theta is equals to 180 degree, so this plane will become here similar. So, here sigma x will be what? Px by 2. Okay. So, here we have our major principal stress and another one, that is minor principal stress. Okay. In principal axis, here principal plane 1 and principal plane 2, right. So, in diagram if you see, here we have the object, our principal plane are present in, one is in vertical direction and another is in horizontal direction. So, this will be our principal plane. Okay. Here PP1 and here you can take PP2. Okay. So, why principal 1 and principal plane 2? Because there is the shear stress presence is 0. Okay. And here you can see, okay, we have the tau values are 0, but tau value is maximum and minimum in case of angle 45 degree and 135 degree. So, we can say if here, if we draw one incline, we cut this plane inclinedly in 45 degree, there will be presence of shear stress. Also, if we cut it, here we have 90 degree, so 135 degree we will have here in this plane. Okay, this is a 135 degree. So, in 135 degree we will have minimum shear stress, right. So, now we will have shear stresses are like in this direction. If we cut this in this plane, we will have shear stress. Okay. So, we will have, if we cut the plane vertically or horizontally, if we cut the plane vertically or horizontally, we will have our principal plane and major principal stress and minor principal stress. Major principal stress and minor principal stress. Okay. And if we cut the object in inclinedly, inclined plane will give us maximum shear stress and minimum shear stress. Okay. So, in this diagram, here we have major principal stress and minor principal stress, and in inclinedly we have maximum shear stress and minimum shear stress. So, in this class we have learned about, first we learn how to find out resultant stress. Here we have found out the resultant stress and stresses at different angles and also incline angle, inclination angle. Here we have stresses at different angles. If we cut the plane into different angles, so what normal stress and shear stresses we have. So, here is the principal plane diagram to understand major principal plane and minor principal plane. So, in this class we have learned about how to find out the stresses at different angles and how to draw proper diagram. So, thank you so much.